so we shall begin by considering a circle in the complex plane. So that is to say, let's just make this clear. The real axis is something like that, and the imaginary axis is there. And what we have is we have a center of a circle. So the center of our circle is this right here. That is our center. And you can see, if it were a circle, then the distance from the center to the point should be equal. And we have chosen a specific length, this one, to depict our radius. And so what the values are is this is being described as the point A. In here, there is the point A. This is being described as the point P up there. And so this could be described in vector-esque language as AP. So you have the origin OA. This therefore would be OP. But considering this is a complex plane, this vector in here could be simply described as just Z there. That is just Z. And also, with regards to OA, we can change that and give it a more specific name, specific to the complex plane, as Z1. So OA is Z1 as I have described here. And this maps out a circle in that this length AP should be the equivalent for all distances. And so AP is the radius, and we have OA is Z1 and OP is Z. Now, let us continue. We are going to now look at a little bit more specific concepts here. We do not need this giant purple line believing it has real estate. Okay, so what we have instead now is I'm just going to describe how we can represent this radius there, AP, by utilizing the complex plane values. Now, so for example, Z, if you consider to get from AP, from A to P, we could instead move down this point here. So we could walk, let's say we would use the word walk, is perhaps not the best word to utilize, but it might aid in this situation. We could walk down Z1, so we're walking down Z1, and then we can walk up Z. And that would get us from A to up down here, up there, to P. And so AP, in terms of the original position and the founder's position, is the same as minus Z1 plus Z. And minus Z1 plus Z, of course, is the same as Z minus Z1, giving us this situation. And I say that again, minus Z1 plus Z gives us AP, because you start at A and finish at P, the same outcome, start at A, finish at P, and you have minus Z1 plus Z, which is the same as Z minus Z1. Hence, we can have this equation to represent the radius of the circle. There we are, we have, and it matched the little wonkiness there, AP is equal to Z minus Z1. Now, we can conclude, therefore, that the radius, let's say it again nice and loud, the radius is Z minus Z1 for this diagram. And I've stated here, therefore, the following equation represents a circle. It contains the information for both the radius and the center. Why? Because Z1 will state the complex plane value of the center. It will be, let's say, for example, this is a value of 2 on the real plane, and this is a value of 1 on the imaginary plane. Then Z1 will be 2 plus I, and 2 plus I will be your Z1, and therefore it will contain the center point in this equation, whilst also being equal to the radius, which will be described as this length here. Okay, that'll do for now.